Hello everyone, welcome back. In today's project, we are going to build complete machine learning project from scratch using the famous Titanic dataset. First, open the Kaggle by using Chrome or Google and log in and search for Titanic machine learning from disaster and click the first one and click data, scroll down and then you will find download all option. Then click it. Then search file manager and go to the file manager and downloads. Then you will get like this in the form of zip file. Okay, double click it, double click, then you will get extract all option and click it. Okay, when you click that, you will get like this. Open that folder and select all and click Control A and Control C. Okay, then go to your desktop, double tap, new, and create a folder. Titanic data, Titanic project, and click enter. Open the folder and paste it. Control V. Yes, we finally created our folder, right? And then now we have to direct this folder to our notebook. Open your Jupyter notebook here. And where did you create it? In the desktop, right? Click the desktop button. And what is the name of your folder? Titanic project, right? Titanic project. Here I have created my folder in previous only. Just for now, I created to make you understand. Okay. Now click it. You will file your folders and now click the new notebook. That's all. Okay. Now let us see our practical session. Just a second. Desktop. And here is our original project. See, I already created a new notebook just for you in the previous only to make you understand and to make you clear. Okay. Yeah, we got it. Right. Okay. See, at the beginning of the session only, I have written all the codes here. Uh, only the reason because to make you understand and to make you clear. Okay. And to save the time also because it will take more time to understand by writing the each line of the code. Okay. Now let us start our session. Now I will ask simple question to you. What is our goal? What is the purpose of this project? What is our goal and what is the purpose of our project? Once ask yourself, why are you doing this project? I will clarify you. Don't worry. Here our goal is to predict whether a passenger survived the Titanic disaster or not. In the Titanic disaster or not. I'm going to explain again. Listen carefully. Our goal is to predict whether a passenger survived the Titanic disaster or not. This is going to be a complete machine learning workflow. We are not going to simply load the data set and train one model. Okay, we will understand all the things here, like importing the libraries, load data set till the save model. Okay, and here, and by the end of this project, you will have proper machine learning project that you can understand and also explain in your resume. Okay, now first one here. Here, what is our problem statement here? See, before before writing any machine learning code, let's clear understand the problem. Okay, just first we have to clear and understand the problem. We have the information about the Titanic passengers, right? Such as age, sex, gender, passenger class, fare, and family information, right? Using these details, we want our machine learning model to predict whether the passenger survived or not. Here our target column is what? Our target column is survived. What is our target column? Survived. If the value is 0, if the value is 0, the passenger did not survived. What? If the value is 0, it means the passenger did not survived. If the value is 1, it means the passenger survived. Because our target has two possible outcomes, and this is called as classification problem. Okay, see, when we have two possible outcomes, on that time it is called as classification problem. What is our problem here? Classification problems. Classification problem. Here we have two types of problems. One is regression problem and another one is classification problems. Here classification problem depends on categories, right? Like yes or no. Okay, here, and this is the workflow here. First we will import libraries and then load data set and data understanding, EDA, data cleaning, everything we will done in this project. Okay, and don't worry about this. We will make it, I will make you clear and I will make you perfect. Okay, and this is the complete workflow we are going to follow now. And I want you to pay attention. I want you to pay attention to this, because this is not just a Titanic project. This is workflow is a general machine learning workflow that you can use in many another projects. Not only these projects, in many another projects. Okay, we start by understanding the problem and data. What? We start by understanding the problem and data, and then we explore and then clean the data. After that, we create the useful features and prepare our data for the machine learning. Okay, first let us start building the libraries. First we have to import our libraries here. What? Now let us start with our Python code. The first library we are importing is pandas. What pandas? Here pandas is mainly useful for working with tabular data. What tabular data? Here our data is in the form of Excel. Excels are on tables, right? That's why we are using pandas here. Okay, we import pandas using the name PD. What? Name PD, which is the standard convention. Okay, and it is the shortcut. And the next one is, what is the next one here? We are importing NumPy. NumPy is a Python library used mainly for the numerical operations and working with arrays. What? Working with arrays. And machine learning involves a lot of numerical calculations. So NumPy is another fundamental library we will use. Okay. And the next one is, we are importing two libraries for the visualizations. What? Two libraries for the visualizations. One is Matplotlib and another one is Seaborn. We will use these libraries later when we perform EDA. EDA means exploratory data analysis. EDA is where we will start visualizations to understand things like survival distribution, like gender versus survival, and passenger classes versus survival and age distributions. Later you will get clarity, okay? Just don't be panic, okay? Later definitely you will get clarity, okay? And the next one is finally we are importing some tools from scikit-learn. What? From some tools from the scikit-learn. See if you want to repair some bike, what you want? Some tools, right? And for the machine learning also we want some tools from the scikit-learn, okay? And here, scikit-learn is one of the most popular Python libraries for the machine learning. And we will use these tools later for splitting our data and scaling numerical features and encoding categorical features and creating pre-processing pipeline. In the future, in the upcoming time, I will explain you everything and don't be panic, okay? We are importing them now so that when we reach the pre-processing section, everything is ready, okay? And here now, okay then, and now we are importing the machine learning tools we all need. We will use, once observe here, we will use train test split. What? Train test split, it will split our data. And the next one is standard scaler and one hot encoder will handle the pre-processing. And the next one is column transformers and pipeline. Column transformers and pipeline will help us create a clean machine learning workflow. And then we will train three models in this project. One is logistic regression, which is very important one, and another one is random forest, and another one is first one is logistic, and next one decision tree, and another one is random forest. Okay. Finally, we will use evolution matrix also and grid search CV for hyperparameter tuning. And the last one is job leap to save our final model. Here we will use job leap to save our model. In this project, we will work all with this. Okay. And the next one is load the data set. What? Now let us load our Titanic set. Make sure the CSV file present in the same folder as your Jupyter notebook. See here. I will explain you. Wait a second. Yeah. Here what is the file name here? What is the CSV file present in it? Train.csv, right? Yes. Same. Here, same folder as our Jupyter notebook. Okay. And the next one is, what is the next one here? df equal to pd dot read csv train dot csv. Here we are using pandas to load the Titanic CSV file. We are storing the dataset inside a variable called df. From now on, df represents our Titanic dataset. And important one. And if you downloaded file has the different names, use the exact same file name. Okay, don't use like this. Okay. And the next one is data understanding. What? Data understanding. See, before building any machine learning model, we should never immediately start training. First we need to understand our data, and we look at first QROS and the size of the data set and the data types and missing values and basic statistics. Okay. First, let us look the first 5 rows of our data set here. What? First 5 rows of our data set. Okay. Let us run all this. Okay. Shift enter, shift enter, shift enter, shift enter, shift enter. Yes, the data set is already loaded, right? Yes. Okay, now df.head. This gives an initial idea about what our data looks like and what kind of columns we have. Now let us run this. 5. See here, we didn't mention any number here. Why? Because df dot head gives uh, the first 5 rows. It means it is default. Okay. Suppose when I mention 10 here, it will give 10 rows like this. And when I mention 20, it will use 20. Okay. Okay. And the next one is shape. What? Shape. Now let us check the shape of our data set here. Shift enter. Yeah. 891 comma 12. What? 891 comma 12. Here the first number represents the number of rows and the second number represents the number of columns. What here? The first number represents number of rows and the second number represents number of columns. Each rows represents a passenger and each column represents a some information about passenger. Okay. And here and the next one is understanding the data types. What? Understanding the data types. Here this is very useful because it tells us the data type of each column and whether there are missing values. We can see which columns are numerical and which columns contain text or categorical information. Now let us run this. Shift enter. Yeah, we got null values and we got the data type here int object. Okay. And the next, missing values. What? Missing now, missing values. Now we are specially checking for the missing values. See, missing values are important because machine learning models generally cannot directly work with the empty values. So before training our models, we will need to decide how to handle them. Okay, we need to decide how to handle them. Okay, now let us run this. Shift enter. Okay, and here the next one is basic statistics. What? Basic statistics. Finally, let us look at the some basic statistical information about our numerical columns. We can see values such as count, mean, minimum and maximum and different percentiles. And this gives us basic statistical understanding of our data sets. Now let us run this. Yes, we got our basic statistics here. And the next one is the most important one, which is EDA. EDA means exploratory data analysis. See, after this video, when someone asks you in the interview about what is what is EDA, and what type of operations you will perform in EDA means, definitely you have to answer to them. Okay, after this video. Okay. And here now we are moving to the exploratory data analysis or EDA. EDA means exploring our data using statistics and visualizations to discover patterns and relationships. We will look at our survival distribution, gender, passengers, classes and age. Okay. Here wait a second. Yeah. The first one is gender versus survival. See, let us run this. Shift enter. You got the output right. What is the output here? SNOS dot count plot. It will count the survived and the number of passengers. Okay. And the next one is gender was survival or gender was survival. Now let us investigate the relationship between gender versus survival. See, if you want this whole explanation in the brief way, in my previous lessons which I already made some videos on the EDA, which means Matplotlib and Seaborn. I already made some videos to you. Just go and check it in the machine learning playlist. Okay. Here the next one is gender versus survival. We are using gender on the x-axis. What here? We are using gender on the x-axis and survival as the color grouping. This helps us visually understand whether survival patterns were different between male and female passengers. Okay. Here sex means, what is sex means? Here sex means male and female. Now let us run this. Shift enter. Yes, we got the output right. And the next one is passenger class was survival. What? Passenger class was survival. Next, let us investigate passenger class. Okay. The Titanic dataset has three passenger class here. We are comparing these class with the survival to see whether passenger class appears to have the relationship with the survival. Now let us run this. Shift enter. Yes, we got the output right. See, don't by heart this code, okay? Just try to understand what I'm saying. And the next one is age distribution. What? Age distribution. Finally, let us look at the distribution of passengers age. Distribution of passengers age. And this graph helps us understand the age range of the passengers. We can also notice that there are missing age values which we'll handle in the data cleaning selections. Let us run this. Yes, we got the output right. And the next one is data cleaning. What? Data cleaning. Now we are moving to the data cleaning. Based on our earlier inspection, we know that some columns contain missing values, right? And we will handle the important missing values and remove columns that are not useful for our current model. Okay? Okay. First, let us handle missing values here. Let us check whether there are any missing values or not. Shift enter. Yes. Age has some missing values and cabin and embarked. Okay. Now we are handling the missing values. We are handling the missing age. Is missing, right? Some we have some null values, right? Now we are handling them. First, we will handle the missing values in the age column. Instead of simply deleting passengers with missing age, we will replace the missing age with some median age. Some median age. See here, why median? Here, the median is useful here because it is less affected by the extreme values. Means less affected by the extreme values than the mean. Okay. Now let us run this. Shift enter. 28.0, right? Replace. It is already replaced, right? Next one is handling embarked. Okay. Next we will handling the missing values in embarked. Embarked is a categorical column. What? It is a categorical column. What? It is a categorical column. So instead of using the median, we will use the most frequently occurring categories, which is called the mode. What? Which is called the mode. Now let us run this. Yes, we got the output right. 2. Okay. And the next one is removing unnecessary columns here. Unnecessary columns. What? Removing the unnecessary columns here. Here now we will remove passengers, name, ticket and cabin. Here passenger is simply an identifier, right? And name. What? Name and ticket could potentially be engineered into the useful features in a more advanced project. But for our current project, we are keeping the future set sample, right? So removing unnecessary information can also make our model easier to understand. And here the cabin also. And here the cabin also. Sorry. Here the cabin also. We are removing the cabin also. Just shift enter. Yes, they are removed, right? Now let us see the output here. Shift enter. Yeah. Okay, we filled the missing values and also we removed some we removed some columns like unnecessary column like passenger ID, name, ticket and cabin. Okay, and the next one is future engineering. What? Future engineering. Here now we are moving to the future engineering. Here what is future engineering? Future engineering means creating useful new features from the information we already have. We will create two features here. One is family size and is alone. One is family size and another one is alone. Now let us start with the family size. What? Family size. Here we are creating a family size. Here SIBSP tells us the number of, here SIBSP tells us the number of siblings or spouses, and Patch tells us the number of parents or children. We are adding one because we also need to count the passengers themselves, right? This gives us the total family size. Now let us run this. Shift enter. Okay, and the next one is e-salon. What? We are creating the e-salon. If the family size is 1, the passenger is traveling alone. So we convert that condition into the 1 for alone and 0 for not alone. What? I'm again repeating. We convert the condition into 1 for alone and 0 for not alone. This creates a simple numerical features that our machine learning model can use. Okay? And the next one is check the new futures. What? Checking the new futures. Let us verify our newly created futures here. We can now see SIBSP and Parch and family size and e-salon together and understanding how the new futures we are created. Okay, and the next one is prepare X and Y. Now we have doubt. What is X and Y? Now we need to separate our input futures from our target. What? Input futures from our target. In supervised machine learning, X presents the informations we gave to the model, while Y represents the answer we want to the model predict. I'm repeating again. In the supervised learning, X X X represents the information we give to the model, while Y represents the answer we want the model to predict. Okay, let us create next here. X equal to df dot drop columns survived. Here we are creating X. X contains all the input futures. So we are removing the survived because that's the answer we are trying to predict, right? I'm again repeating. X contains all the input futures. We are removing survived because that's the answer we are trying to predict. Okay. And the next one is create a Y. What? Create a Y. Now we are creating Y. Y contains only our target variable. What? Only our target variable. What is our target variable here? Survived, right? Now 0 means the passenger did not survive, and 1 means the passenger survived. We already discussed it previously, right? 0 means the passenger did not survive, and 1 means the passenger survived. Okay. Now let us check the shapes here. Shift enter. Wait a second, sorry. Shift enter. Shift enter. Yes, you got the output. Once observe it. Shift enter. Shift enter. Now we will get shapes. Right? Here shapes. Let us quickly check the shape of X and Y here. See here, both should contain the same number of passengers. What? Same number of passengers, because every input row has one corresponding target value. I'm repeating again. Both should contain the same number of passengers because every input row has one corresponding target value. Okay. And the next one is the most important one: train, test, split. What? Train, test, split. Now we will divide our data into the training and testing sets. Here the model will learn from the training data, while the testing will kept aside to evaluate the model on unseen passengers. I'm repeating again. Here the model will learn from the training data. What? Training data. While the testing will kept aside to evaluate the model on the unseen passengers. Okay. And the next one is split the data. What? Split the data. We are using 80, 80. We are using 80, 80 to 20 split. Here it means 0. See, I will explain you. Around 80% of the data will be used for the training and 20% will be used for the testing. Here test side 0.2 means it is 20%. 20% goes to the testing and 80% goes to the training. Okay. And here random state. A random state 42 makes the split reproducible. Okay. Random state for 42 makes the split reproducible. Okay. Now let us check the split here. Shift enter. Yes, we got the output right. Here let us verify our split. We can see that x train and x test contains the same features, right? But different number of rows. But different number of rows. The test data will remain unseen during the training. What? The test data will remain unseen during the training model. Okay. And the next one is pre-processing. This is the most important topic in the entire machine learning. What? Data pre-processing. What? Data pre-processing. Our dataset contains both numerical and categorical features. Numerical and categorical data require different pre-processing methods. So we will handle them separately and combine them using column transformers. What? Using the column transformers. Here numerical features. What? Numerical features. Numerical features equal to x dot select data types include int64 and float64 dot columns. Here we are automatically identifying our numerical features. Here this is better than manually typing every column because our code can identify the numerical columns from the data set. Okay. And the next one is identifying the categorical columns. What? Identify the category columns. First, let us run this. Shift enter. Yes, these are the numerical columns. See, age has numbers, siblings has numbers, etc. Okay. And the next one is identifying the categorical columns. We are now identifying our categorical features. In our data set, columns such as sex and embarked contain the categorical values. Now let us run this. Shift enter. Shift enter. Yeah, we got the output right. And the next one is numerical transformers or numerical pre-processing. Here for numerical features we are using standard scaler. What? Here for the numerical features we are using standard scaler. Here scaling brings numerical features on onto a comparable scale. Here this is especially useful for models such as logistic regression. Okay. And the next one is categorical pre-processing. What? Categorical pre-processing. For the categorical features, we are using one hot encoder. What? One hot encoder. This converts categories such as male and female into numerical representation that machine learning models can understand. Okay. And here a handle unknown. What? Handle unknown equal to ignore. Also makes our pipeline safer when we later predict new data. Okay. And the next one is creating the column transformer. What? Column transformer. Now we are combining both pre-processing methods. What? Both pre-processing methods. Numerical features will go through the standard scaler. What? Numerical transformers go through the standard scalars. And categorical features will go through the what? Will go through the one hot encoder. Okay. Column transformers allow us to manage both automatically. What? Both automatically. Now let us run this. Shift enter. Shift enter. Shift enter. Okay. Now let us create the first pipeline here. What? Let us create the first pipeline. Here now comes the existing part. We are going to train three different machine learning models and comparing them. Our models are, first one is logistic regression. First one is logistic regression. And the another one is training a decision tree. And another one is random forest. Okay. Let us start with the logistic regression here. What? Let us start with the logistic regression. Here first we are creating the pipeline for logistic regression. Here, the advantage of using a pipeline is that pre-processing and model training become part of one complete workflow. I'm repeating again. The advantage of using this pipeline is that pre-processing and model training become part of one complete workflow. Okay. Now let us run this. Shift enter. Shift enter. Shift enter. Okay. Let us run this. Shift enter. Yes. Created, right? Shift enter. Yeah, we got it right. Here, now we are training logistic regression using our training data. Here, the pipeline automatically performs the required pre-processing before training the model. And the next one is decision tree. What? Decision tree pipeline. We are creating the decision tree pipeline. Next, we are creating our decision tree pipeline. A decision tree pipeline learns a series of decision rules from the training data. What? A decision tree learns a series of decisions rules from the training data. Now let us run this. Yeah. Now we are training our decision tree using the same training data. Okay. Same training data. And the next one is training the random forest. What? Training the random forest. Here, finally, we are creating our random forest pipeline. Here, random forest combines multiple decision tree. Here only one decision tree, but random forest means multiple decision trees. What? Multiple decision trees to make predictions. Here we are starting with the 100 trees. What? 100 trees. Now our random forest is trained. We have successfully trained all three models, right? And then next one is model comparisons. Here these are the predictions. Wait a second. Yeah. And the next one is the model comparisons. What? Model comparisons. Now we are going to use our trained models to make predictions on unseen test data. What? On unseen test data. Each model will make its own predictions which will compare next. Okay. Here let us start with the accuracy. What? Accuracy. Now we are calculating the accuracy of all three models. Here accuracy tells us how many predictions were correct out of all the test predictions. I'm repeating again. Here accuracy means it will tells us how many predictions were correct out of all the test predictions. We will use these results for our initial model comparisons. Okay. Yeah. Okay, let us put our result into a clean comparison table. What? Let us put our result in a clean comparison table. This makes it easier to compare the three models and it will attract your interviewers also. Okay, but we shouldn't choose our final model based only on this single test list. Next, we will use one of the most important one, which is cross validation. What? Cross validation. Now let us run this. Yes, we got the output right. Okay, okay. And this is the best model for us, which is random forest. Okay. And the next one is cross validation. What? cross validation. See, a single trend test splits can sometimes use us lucky or unlucky result. On that time, we will use cross validation. Cross validation helps us get more reliable estimate of the model performance. We will use fivefold cross validation here. What? We will use fivefold cross validation. Yeah, first let us run with the logistic cross validation. First, let us discuss about the logistic cross validation. We perform fivefold cross validation for the logistic regression. Here, the model is trained and the validate multiple times using different parts of the training data. Finally, we will use the mean score more reliable performance estimate. Okay, more reliable perform estimate. Let us run this. Yes, we got the output right. And the next one is decision tree cross validation. What? Decision tree cross validations. Now we are doing the same fivefold cross validation to our decision tree. Let us run this. Okay. Shift enter. Shift enter. Yes, we got the output right. And the next one is random forest. Finally, we are performing the fivefold cross validation for the random forest. Now we have a more reliable performance estimated for all three models. What? For all three models. Now let us run this. Yes, we got the output, right? And the next one is cross validation comparison here. What? Cross validation comparison. Here, a cross validation comparison, we will use these mean scores to identify our strongest candidate for the further tuning. What? Here, our cross validation comparisons are going here. We will use these mean scores to identify our strongest candidate for the future tuning. Let us run this. Yes, we got the output right. Okay then. And the next one is best model. CV best model. What is the best model here? Logistic regression, right? And here the next one is hyperparameter tuning. What? Hyperparameter tuning. Now we will perform our random forest using hyperparameter tuning. What? Hyperparameter tuning. Hyperparameter tunings are the settings. Sorry, we got here another one, but we are going with the random forest only. Okay. See here, just focus on what I'm saying. Now we will improving the or random forest using hyperparameter tuning. Hyperparameter are the settings that we choose before training. Instead of guessing the best settings, we will use the grid search. What? Grid search to test multiple combinations. What? To test multiple combinations. Let us run this. Here we are defining the random forest settings that we want to test. We are testing the number of trees, maximum trees, depth, and minimum samples required to the split a node. Because random forest is inside our pipeline, we use model before the parameters names. Okay, let us run this. You got the output right. The next one is, what is the next one here? Grid search CV. Now we are creating grid search CV. It will test the different combinations. What? It will test the different combinations using fivefold cross validation and select the combination with the best accuracy. What? With the best accuracy. Now let us run this. Shift enter. Okay. Just a second. Okay. Here we are going to find the best parameters. Now let us see which hyperparameters perform best. What? Which hyperparameters perform best. Here, these are the settings selected by the grid search CV based on the cross validation. What? Based on the cross validation. Okay. And the next one is best CV score. What? Best CV score. Best CV. CV means cross validation. This gives us the best mean cross validation accuracy found during our hyperparameter search. Yes, we got our score, right? The next one is final model. What? Final model. It will get the best model here. Grid Search CV has already built the best performance pipeline for us. We are storing that pipeline as our final model candidate. Notice that notice that this contains both pre-processing and our random forest. Now let us run this. Yes. Okay. Notice that this contains both pre-processing and our tuned random forest. Okay. And here the next one is final prediction. What? Final prediction. Here now we are using our final tuned model to make the predictions on the unseen test data. What? Unseen test data. Next, let us discuss about the evolution. What? Evolution. First, we will calculate the final models. What? First, we will calculate the final models accuracy on the unseen test data. This gives us the percentage of the test passengers that our model predicted correctly. Okay, that our model predicted correctly. And next one is confusion matrix. What? Confusion matrix. Now we are looking at the confusion matrix. It tells us not only how many predictions were corrected, but also what type of mistakes were our model made. Okay, let us run this. Wait a second. This is the final model accuracy. Yeah, this is the confusion matrix here. Okay, here this visualization makes us the confusion matrix. Wait a second. Yes, this visualization makes the confusion matrix easier to understand. Here the rows represents. Here the rows represents the actual values and the columns represents the model prediction. Okay, here the rows represent the actual values and the column represents the model prediction. Next one is classification report. What? Classification reports. Finally, we are looking at the classification report. It gives us precision, recall, and F1 score in the addition to accuracy. And this gives us more complete understanding of our model performance. What? Model performance. Let us run this. Yes, we got the output right. And the next one is new passenger prediction. We are going to predicting the new passenger prediction here. Now let us use our model on the completely on new passenger. This passenger was not part of our training or testing data. We are creating the same futures that our model expects. Okay, let us run this. Yes, we have these columns and the prediction. Next one is prediction. Now we are giving these passengers to our training model. This pipeline automatically performs the necessary pre-processing and generates the prediction. Okay. Okay. And here if you want the human readable, here instead of showing just 0 or 1, we are converting the prediction into the simple message. Like remember, this is the machine learning prediction, not a guarantee of what would be actually happen, right? Let us run this. Yes, here the passenger is likely to survive. Here we have some Error, not an error. Yes, it is shown one, right? But we want in a human readable results. On that's why I have created this. Okay. Here what it predicted, passenger is likely to survive. Here our goal is to whether the passenger is survived or not in the Titanic disaster. Here 1 means the passenger is survived. Here 0 means the passenger is not survived, right? And the next one is saving the model. What? Saving the model. I already told you that Jolib, about the Jolib. Now we are going to save our training models. We are saving the complete pipeline as the Titanic survival model.pkl. This means we don't have to train the model again every time we want to use it. Okay, let us run this. Sorry. Yes, let us run this. Yes, we already got it. And the next one is load the model. What? Save and load the model. Let us make sure our saved model can be loaded successfully. This stimulates what we would do in the real machine learning application. Okay, it is already loaded and saved. And the next one is testing the loaded model. Here make predictions using the saved. Let us run this. Yes, we got the prediction right. 1, it means the passenger survived. And the next one is final conclusion. What? Final conclusion. Here we successfully completed our Titanic survival prediction machine learning project from scratch. We started by understanding the data set. Uh, Wait a second. By understanding the data set, and we performed the exploratory data analysis to discover patterns. We handled missing values and the cleaned our data and created the new features such as family size and ease alone. And then we created our input features and target and performed a train split. And then we created a pre-processing pipeline for the both numerical and categorical data. And after that we trained three different machine learning models, which is logistic regression and decision tree and random forest. We compared their performance using the accuracy and cross validation. Then we performed hyperparameter tuning using grid search cv to find better random forest settings. We evaluate our final model using the accuracy with confusion matrix and classification report. Finally, we use the model to predict a completely new passenger and saved our training model as a PKL file. So this project demonstrates the complete machine learning workflow from data to a reusable trained model. Okay. Uh, I hope you understand. See, don't panic about whole things. We can't cover all completely. Here I'm not. Here I'm not to uh, spoon feed you. Just you have to learn yourself. Just I gave some clarity to you. See, while you're learning machine learning, not only machine learning, just remember three things: what you are learning, and why you are learning, and why not. See, for example, you are learning machine learning. Learn what is machine learning, and then learn why is machine learning, and then learn why not machine learning. Okay, I hope you understand. Please subscribe the channel for more videos. Please subscribe the channel in the future sessions. If you support me in the future sessions, definitely I will make videos on deep learning projects and NLP projects. And also I'm going to start agentic AI and generative AI in the future sessions. Okay, then if you support me, definitely I will make the sessions. Thank you.